In this video, I want to talk about exponential functions. Exponential functions are in the form y equal to a times b to the x power, where a and b are both positive and b is not equal to 1. And exponential functions help us generalize geometric sequences. So let's look at what a geometric sequence is. In a geometric sequence, we multiply by the same number repeatedly. As an example, 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, times 2 is 96, etc. And in this case, we actually can write this equation as y equal to 3 times 2 to the x. The 3 will come from the starting number in our sequence, and the 2 from our multiplication number, the number that we multiply by repeatedly. So we can see this in a table to see the y-coordinates being repeatedly multiplied by the same number. And there's another pattern of change as well. The change in an exponential function is another exponential function. So let's look at some examples. Here I have a table, and if I look at my outputs, we have 1 times 3 is 3, times 3 is 9, times 3 is 27, times 3 is 81, which should indicate exponential. Let's go ahead and look at the second pattern as well. To get from 1 to 3, I could also add 2. 3 to 9, I add 6. 9 to 27, I need to add 18. And 27 to 81, I need to add 54. Once again, we can see 2 to 6 multiplied by 3, 6 to 18 is a times 3, and 18 to 54 is a times 3. So the change gives me another exponential function. Here I have another example. To get from 5 to 10, I would multiply by 2. 10 to 20 is times 2. 20 to 40 is times 2, and 40 to 80 is times 2. So this one would also be an exponential function. We can use exponential functions to model situations where the growth of a quantity depends on how much is present. Examples include borrowing money on credit, populations, and decay of radioactive substances.